The Fermi Paradox. It's a cosmic head-scratcher, a stark contradiction between the high probability of extraterrestrial civilizations existing and the complete lack of evidence for them. Where is everybody? Countless complex solutions have been proposed, ranging from the Great Filter to dark forests. But what if the answer isn't some exotic, mind-bending phenomenon? What if the solution to the Fermi Paradox is staring us right in the face, obscured by our own biases and limitations? Perhaps the truth is so obvious, we've simply overlooked it. One of the most straightforward and perhaps unsettling explanations is self-destruction. Advanced civilizations, in their pursuit of progress, may inevitably sow the seeds of their own demise. The potential causes are numerous and chillingly familiar. Nuclear war, a constant threat looming over humanity, could easily wipe out a civilization. Environmental collapse, driven by unsustainable practices, could render a planet uninhabitable. And then there's the specter of self-replicating machines, spiraling out of control and consuming everything in their path. The beauty, or perhaps the horror, of this solution lies in its simplicity. It doesn't require invoking unknown physics or alien psychology. It relies on observable patterns in our own history.
It highlights the inherent risks that come with technological advancement.
The very tools that allow us to reach for the stars could also be our undoing. We see the potential for self-destruction within our own species every single day. Is it so far-fetched to imagine that other civilizations might face the same existential threats? It's a plausible, if grim, fate for any species that reaches a certain level of technological sophistication. Another surprisingly simple explanation centers on the sheer vastness of space. The distances between stars are so immense that communication becomes incredibly improbable. Even traveling at the speed of light, it would take thousands of years to reach even the closest star systems. This time requirement presents a significant barrier to interstellar communication. Signals, even powerful ones, weaken with distance. By the time they reach another star system, they might be too faint to detect against the background noise of the universe.
And even if a signal is detected, there's no guarantee that anyone will be around to receive it.
Signals might arrive long after the sending civilization has vanished, lost to time and cosmic events.
This explanation underscores the truly staggering scale of the universe.
It reminds us that even with advanced technology, we are still bound by the laws of physics and the limitations of distance. The challenges of interstellar travel and communication are immense, perhaps insurmountable. Maybe the universe is teeming with life, but the distances are simply too great for us to ever know. Perhaps we're not looking in the right places or in the right ways. Our current search methods are based on assumptions about what extraterrestrial civilizations might be like. SETI, the search for extraterrestrial intelligence, primarily focuses on detecting radio signals. But what if advanced civilizations have moved beyond radio technology? They might be using communication methods that we don't even understand yet. Perhaps they've discovered ways to transmit information using quantum entanglement or other exotic phenomena. Or perhaps civilizations intentionally avoid contact, adhering to a zoo hypothesis. They might be observing us from afar, like scientists studying animals in a zoo, without interfering in our development. It's also possible that they're simply not interested in communicating with us. They might have deemed us too primitive or too dangerous to interact with. The universe is vast and full of possibilities. We must consider that our current search methods might be fundamentally flawed, blinding us to the signals that are all around us.
We are understandably searching for life as we know it,
carbon-based life forms that rely on water as a solvent. But what if life can exist in forms that we cannot even comprehend? Different elements and energy sources might be utilized in ways that defy our current understanding of biology. Silicon-based life, or life that thrives on methane instead of water, might be common in the universe.
Our limited perspective, shaped by our own terrestrial existence, might be blinding us to the true diversity of life in the cosmos.
We are, after all, only looking through a very narrow window.
We may be surrounded by extraterrestrial life, but we simply don't recognize it. It might be so alien, so different from anything we've ever encountered, that we dismiss it as natural phenomenon. The universe is full of surprises. We must be open to the possibility that life can exist in forms that are far beyond our current imagination. The Fermi Paradox is a profound question that has captivated scientists and thinkers for decades. Perhaps the solution doesn't require complex physics or mind-bending theories. Maybe the answer is a combination of factors, a confluence of self-destruction, vast distances, limited search methods, and a fundamental misunderstanding of life itself. These seemingly obvious solutions offer a sobering reminder of the challenges we face in our quest to understand our place in the universe. They highlight the fragility of civilizations and the limitations of our own knowledge. The Fermi Paradox, in the end, is a testament to the vast uncertainties that still surround us. It reminds us that we are just beginning to explore the cosmos, and that the answers we seek may be far more complex, or far more obvious, than we ever imagined.